from a 2015 paper 2 question 1. A house is valued at £240,000. It's predicted to rise by 2.8% per annum. Calculate its predicted value after 2 years. Step 1's always the same. We need to find the multiplier, what we're going to times by. So we're starting off with 100%. And it's rising by 2.8%. So that gives me 102.8%. Now we need to change that to a decimal. So we'll do 102.8 divided by 100. And to be safe, I'll use a calculator. 102.8 divided by 100, 1.028. So that is my key number, that's my multiplier, because now what I'm going to do is take my £240,000 times my multiplier, and it's to the power of however many years of a time frame, so in this case 2. 240,000 times 1.028 to the power of 2. And I get 25362816. 253628.16. Last thing, don't forget your pound sign. A function is defined as f of x equals 3x plus 2. Given f of a equals 23, find a. Well, f of a equals 3a plus 2, so that equals 23. Solving that equation, 3a must be 21, and therefore a equals 7, and we're done there. The cosine rule, let's look at some past paper questions. Remember, cosine rule is also given to you in the exam paper. The key points with the cosine rule are, if you're given all 3 sides of a triangle, you can use the cosine rule to find an angle. If you're given one angle but 2 sides that go across the angle, you can use the cosine rule to get the other missing side on the other side, okay? So let's have a look at this. 8th grade National 5 Maths 2015 paper 2 question 3 says triangle A is shown, calculate the length of AB, so I have to calculate this length here. Remember, the cosine rule at the start of the exam paper says a squared equals b squared plus c squared minus 2bc cos A. But that is when A is the angle in the opposite side. All you need to remember is the 2 sides go across the angle. If that's the case, that's your 2 sides, your B and your C, and that's your angle. So I can immediately just say that I've got 1.2 squared plus 1.35 squared minus 2 times 1.2 times 1.35 times the cos of 35 degrees. And if you can get that far, you get a mark. So remember, that's squared. I'm just calling this A to be clear. So you need to do some work in your calculator. You can do it all in one stage, or you can do it in bits. If you're going to do it all in one stage, you could put that brackets around this bit minus brackets around this whole bit, and it'll give you your answer in one stage. Or you could do the answer to that and write it, minus the answer to that and write it, and take your time. Whatever you do, as long as you be careful with your calculator, you will get 0.608. And a bunch of our numbers. And then you just square root your answer, because that's a squared, so a is the square root of the answer I just found out, which is equal to 0.78 kilometres. It's been National 5 Maths 2015 paper 2 question 4 on magnitude of a vector. Find the size of u, the magnitude of vector u. So that is just like Pythagoras, remember. All you do is square each number, add them up and square root it. So the size of u is equal to the square root of 6 squared plus minus 13 squared plus 18 squared. And we've got a calculator for this. I'll do the bit in the square root sign first. 6 squared plus minus 13 squared, make sure you use brackets around that, plus 18 squared. That gives me 529, so I need to do the square root of 529. Square root of 529 is exactly 23. And we're done there. It's been National 5 Maths 2015 paper 2 question 5 on vectors. Vectors P and Q are shown in the diagram. Find the resultant vector P plus Q. Express your answer in component form. Okay, there's 2 ways to do this. You can either draw a diagram where you add P and Q together on a diagram, or you can do what I prefer, which is to work out what P and Q is and then just add them together. So I'm going to do it that way. So P starts here and ends up there. So I just need to work out how far along, how far up. So P is equal to, it goes along 1, 2, 3, 4, 5 to the left. So that's minus 5. Once I've hit there, it goes up 1, 2, 3. So that's positive 3. So there's my P. Doing the same for Q. So Q, remember, starts here and it's going down to here because of the arrow. So you always go along first and then down. So I'm going to go along. Starting here, I need to go right. 1, 2, 3, 4. I've went right, so it's positive. And then I need to go down, so it's negative. 1, 2, 3, 4, 5. So it's negative 5. And now I just need to add these two vectors together. P plus Q is equal to minus 5, 3, plus 4 minus 5. Add in the top, minus 5 plus 4 is minus 1. Add in the bottom, 3 plus minus 5 is minus 2. We get minus 1, minus 2, and we're done there.
2015, paper 2, question 6 on volume. We've got two parts to this. Part A says the Earth is approximately spherical with a radius of 6,400 kilometres. Calculate the volume of the Earth, giving you an answer in scientific notation, correct to two significant figures. And then part B says the approximate volume of the moon is 2.2 times 10 to the 10 cubic kilometres. Calculate how many times the Earth's volume is greater than the moon. Okay, so let's start off with part A, which is a straight volume question. Once we've done part A, we're going to do part B, which is a scientific notation question. 6A, since we're using a sphere, it's 4/3 pi r cubed. Get that from the start of the exam paper. So that's 4/3 times pi times the radius 6,400 cubed. That equals 1.098 times 10 to the 12, which we round that to two significant figures. So that's 1.1 times 10 to the 12 kilometres cubed for a final mark. Part B, the approximate volume of the moon is 2.2 times 10 to the cubic kilometres. How many times the Earth's volume is greater than the moon's? How many times? So I need to do the Earth's volume divided by the moon's volume. So step 1, identifying that we need to divide. So we do 1.1, the big number, times 10 to the 12, divided by, or the divide sign, 2.2 times 10 to the 10. Get a mark for that. And then once we divide, just make sure we put that in the calculator with brackets, divided by brackets, you get 50. And we're done there.
2015, paper 2, question 7, divide. So remember, divide means divide changes to times, and with times by the reciprocal of the second fraction. We turn the second fraction upside down. So if we do that, look at it, we are going to get 5t over s times 2s squared over t. Now we simplify in advance. So the t's can go, we can divide by an s, and to get an s on the top still. And that's it. So we've got 5 times 2 is 10, 10s. Nice, done. Okay, reverse percentages, but this time with a calculator. Still 2015 paper 2 question 8. It says James paid £297.50 for a laptop in a sale. The discount in the sale was 15%. Calculate the original price of the laptop. Here's a tip, there's no time in this question, so it's probably reverse percentages. We start off in the same way by doing the multiplier. So we've got 100%. It was in a discount, so it's been taken off, so minus 15%. That leaves 85%. Change that to a decimal in the normal way. Divide by 100 to get 0.85. So now, since we're going backwards, we're not going to times by 0.85 because we're going to try to get back to the original price. So we divide by 0.85. So 297.50 divided by 0.85. Calculator time. Exactly 350. So our answer is £350. Notice there's no time in this question. If you don't notice time, it might be divide. Look for things like original price. Good answer 5 Maths 2015 paper 2 question 9 on similarity. A flag at each hole where a golf course is coloured red and blue. The diagram shows the flag. It says triangle QRT is red and PQTS is blue. So this small triangle is the red bit, and then this bit here is the blue bit. And it says they're similar, so it's similarity. The area of a triangle QRT is 400, find the area of the blue section. So if I know that that's 400, I can use similarity to get the area of the whole triangle, and then just take away that triangle to get the blue bit, which is missing. So that's what I'm going to do. So for similarity, we've got linear scale factor, then it scales up to area and volume. So first of all, starting off with linear scale factor, I want to find the big one. So it's big over small. So our linear scale factor is equal to 30 over 24. Now you can simplify it or not, it's no point because it's a calculator question, so we'll just move on. We want to find the area. So the area scale factor, that should say F of course, is just 30 over 24 squared, because it's area. So that means that my big area is equal to the scale factor times my small area, which is 400. So I get my calculator out. 30 divided by 24 in brackets squared, and then I'm timesing by 400, and that gives me 625 centimeters squared. So now that's given the whole triangle, so the area of the blue section is just 625 minus the small triangle 400. Using a calculator you get 225 centimeters squared, and we're done there.
So on arc length, we've got SQA National 5 Maths 2015 Paper 2 Question 10. Had this question: the pendulum of a clock swings along an arc of a circle with centre O. So you've got 65 degrees here. The pendulum swings through 65 degrees. The length of the arc is 28.4. Calculate the length of the pendulum. So we're working backwards from arc length, but it mentions length of arc, so we can substitute in. So the writing down arc length, again, equals angle over 360 times pi times diameter. When we substitute everything in we've got, so it's told us the arc length is 28.4, so I can write 28.4 equals our angle, which is 65, over 360 times pi, but I don't know the diameter, so I can just write times diameter. Now I find the easiest way to work back here is you could either try and rearrange it directly, or what I like to think of is, usually I do divide by 360 and times by everything else. So for going backwards, I'll do the opposite, which means I'll times by 360 and divide by everything else. So I can immediately write down that D equals, starting with 28.4 on the left-hand side, I'm going to divide that by, well, everything on the top is normally times. So 65 times pi is going to go in the bottom. Then the thing that's usually divided is 360, so I'm going to times the top by 360. And I get my D straight away that way. And then I just go to a calculator and work that out. So I just do 28.4 times 360, and then divide by 65 times pi. I can use brackets around the top and brackets around the bottom. And if you do that, you will get an answer for D, which is 50.07 centimetres. Now, we'd usually be finished here for calculating the diameter, but it asks us to find the length of the arc, the length of the pendulum. Well, if that was to go all the way around, it would be a circle, and that would be a radius. So the length of the pendulum is half that. So our length is equal to 50.07 divided by 2, which to a reasonable degree of accuracy is 25 centimetres. National 5 Maths 2015, Paper 2, Question 11 had this question. The tabletop is in the shape of a regular hexagon. The three diagonals are shown in dotted lines below. Each have a length of 40. Calculate the area of the tabletop. So we know that each of these lines here, the diagonals, are 40, which means half in it, these will be 20. Now, it's an area of a triangle question in disguise. There's a bunch of triangles here, not all the same size. So if I draw one of the triangles, you should be able to see that it is an isosceles triangle, not an equilateral triangle. And therefore, every angle is 60 degrees. The way to find out it's 60 is because it is a hexagon, There's 1, 2, 3, 4, 5, 6 angles around the centre. 360 divided by 6 is 60. And now we can use area of a triangle. So let's look at this triangle. We can call that C, A and B. That could be A, and that could be B, sorry, and that could be A. So now area is a half AB sine C. So that's 0.5 times 20 times 20 times the sine of 60 degrees. Again, it's a calculator question, so just get your calculator out and work it out. That'll be 173.2 square centimetres. But if we go back to the original question, you'll notice that there's 1, 2, 3, 4, 5, 6 triangles in there. So our total area, we need to times that by 6. Get 1039.2 centimetres squared for our final answer. National 5 Maths 2015 Paper 2 Question 12. The diagram below shows a cross-section circle of a milk tank. The depth of the milk is shown here. The radius of the circle centre O is 1.2 metres. The width of the surface of the milk in the tank is represented by ML as 1.8. Calculate the depth of the milk. Quite a standard question this, where it looks like a kind of circle with a bit chopped off, or sometimes you get a tunnel. And quite often, if you have to calculate a length inside a circle, this will be Pythagoras, and you have to make a right angle triangle somehow. So let's just take some information we're given and put it on the diagram. The radius is 1.2. So we could go from here to here is 1.2. We know the width of the milk in the tan is 1.8. So if I draw a line up to here, it'll meet it at right angles. And we know that that's going to be 0.9. And we have to calculate the depth of the milk in the tank. Well, we know the distance from here to here is already the radius. So if I can calculate this little bit, I can just add them together to get the depth. So I'm just going to call that bit x. If you can get a diagram that looks like that, a right angle triangle, you get a mark already. You then just need to work with that. So we're finding the shorter side of a right angle triangle. So x squared is going to be 1.2 squared, take away 0.9 squared, because I'm finding the shorter side. And you get a mark for writing that down. And then a mark for calculating x, which is the square root of our answer. Our answer is about 0.63. That gives me 0.79. So then the depth of the milk must be 0.79 plus the radius already, because it then continues another 1.2. That gives you 1.99. And the units are metres. And we're done there. 2015 Paper 2 Question 13. In the diagram below, PQ and R represents the positions of Portlee, Queenstown and Rushton. And it says Portlee is 25 kilometres due south of Queenstown, which we've drawn for us. It says that Portlee is on a bearing of 72 degrees from Rushtown. Well, there's a north line, so we've drawn the 72. And it says, from Queenstown, the bearing of Rushtown is 128 degrees. Calculate the distance between Portlee and Rushtown. We need to know what it's asking us and maybe mark up our diagram. So let's, first of all, distance between Portlee and Rushtown is this distance here. So let's put a little mark on that. Let's just call that X for the now. And then it tells us one more thing. It tells us the bearing of Rushtown is 128 from Queenstown. So always notice the way they say this. From Queenstown means starting at Queenstown, going north, measuring clockwise until I'm looking at Rushtown is 128. So I can immediately write down 128 degrees in here. Okay. Remember, the strategy always is try to get some angles inside the triangle. Once you've got as many as you can find, use the sine rule or cosine rule. So in this case, I've got north going all the way around to here. That's a half a turn, or angles on a straight line add up to 180. So I can do 180 minus 128. That gives me 52 degrees. and I can write 52 inside this triangle here. I don't know anything about this angle, but I've got two angles in a triangle. I've got one side and a missing side, so I can use the sine rule. I can always find this angle if I need it, because angles in a triangle add up to 360. A over sine A equals B over sine B, so I'm going to need this angle. 72 plus 52 is 124. So I can do 180 minus 124, which is 56 degrees. And that can go in here. So now remember from our sine rule, if we go to the back start of the exam paper, it says that A over sine A equals B over sine B, which equals C over sine C. That is really just telling us that angle with opposite side, angle with opposite side, angle with opposite side. So I can go these pair equal these pair. So let's just write that in. 25 is the side over the sine of the angle 56 equals, let's call our side x, or A, or B, whatever you want. I've written x over sine 52. Opposites, opposites. So there's a mark. Where's our mark so far? We've got a mark for getting the 52 inside this triangle, and we've got a mark for working out this. You could have called this Q, of course, because it's opposite Q. Now we need to rearrange this, so using cross multiplication is the easiest thing. 25 times sine 52 equals x times sine 56. X sine 56 equals 25 sine 52. So x equals 25 sine 52 degrees divided by sine 56 degrees. You get a mark for correctly rearranging your formula to get your side. And then your final mark for calculating it. So it's just a calculator job now. 25 times sine 52, then divide by sine 56. X would equal 23.8. And the units were kilometres for your final mark there.
It's been asked by Maths 2015, paper 2, question 14 on quadratics. A rectangular piece, picture measuring 9 by 13 is placed on a rectangular piece of card. The area of the card is 270, and there's an X border all the way around the sides. To write down an expression for the length of the card. Now, don't worry about this question. I've still got to solve a quadratic for parts B, which is worth 4 marks. So if you can't do the first 2 parts, still just skip ahead to part B. Okay. Right, part A, calculate the length. So for part A, 1, well, our length is, we can just trace this out, x plus 13 plus another x. So that's 2x's plus 13. Part 2. Hence, show that 4x squared plus 44x minus 153 equals 0. It doesn't seem to tell you much, but it's basically we're going to use the area because the area of the card is 270. So I write down what the area is. It's this length times the breadth. So our area equals 2x plus 13 times. Now we've got 9 plus another 2x, so 2x plus 9. And we know that that equals a total area of 270. So we can expand and simplify. So expand on the left, 2x and 13, 2x and 9. That still equals 270. And we've got 2 times 2 is 4x squared. 9 times 2 is 18x. 2 times 13 is 26x. And 9 times 13, use a calculator if you have to, you get 117. So that's 4x squared. 26 plus 18 is 44. X plus 117 equals 270. The rest is equal to 0, so I'll take away 270. So that's minus 153. So we get 4x squared plus 44x minus 153 equals 0, which is exactly what we have got. So we're done there. Part B is a big bit. Calculate x, the width of the border. It says give your answer correct to one decimal place. So we've got a quadratic with x in it, and it equals 0, so we can just solve that quadratic. But since we have to make it to one decimal place, it's not going to factorise, so we're going to go to start of exam paper and use the quadratic formula. If you go to start exam paper, you would find that x is equal to minus b, plus or minus the square root of b squared minus 4ac, all over 2a. Now, a is 4, b is 44, and c is minus 153. So we'll just substitute in. So we've got minus 44 plus or minus the square root of 44 squared minus 4 times minus 153 all over 2a, 2 times 4. So being very careful with substitution, watching for double minuses. We've got minus 44 plus or minus the square root. Use our calculator for that bit. So 44 squared minus, open brackets, I'll usually think about brackets being around here, 4 times minus 153, close the brackets, 4384. All over 2 times 4 is 8. That gives me two answers, remember. X equals minus 44 plus the square root of 4384 over 8. Or x equals minus 44 minus the square root of 4384 over 8. So working out our two answers. Minus 44 plus the square root of 4384 equals this. Press equals, press divide by 8. And we get 2.776. Always write down unrounded answers first, which is to one decimal place, 2.8. So now we'll do our other one. You can use brackets for this as well. Minus 44 minus the square root of 4384. Close the brackets, press divide by 8. Press equals. This one equals minus 13.776. So to one decimal place, minus 13.8. We've got two answers, but we have to calculate x, the width of the card. So this is a question in context. It can't have a negative length or negative width. So we can just disregard this one by crossing it out and say that x equals 2.8. Is it in any units? Centimeters. Centimeters. And we're done there. So make sure you correct the correct one and make it very, very clear that that's the one you want. For normal quadratic equations, you'll have two answers, but for this one, just one you need to pick because you can't have a negative length. And we're done there.